Hello everyone and welcome back to another Universe Sandbox 2 video. Now today, before I get into what we are doing, I've got a little challenge for you guys watching the video. So currently we're at 187 subscribers, but I've got a little challenge. So can we get to 200 before the end of the month? So right now we have 8 days till the end of the month as of recording this. So can we get to 200 before the end of the month? That's my first little challenge. I've never really set a subscriber goal before, so yeah, can we do that? So make sure if you're watching right now, if you're not subscribed, make sure you click the subscribe button and help me make my day, I guess. I don't know. Is that good? Or if you just want to watch a video, then watch a video. I'm not forcing you to sub, so yeah, that's that. But anyways, enough of all of that rubbish. Let's get into this. So, after I uploaded my last video about turning Saturn into a star, I got 2 comments saying turn Ganymede, which is the largest moon in the solar system in orbit of Jupiter, into a star. So, I actually really like the idea of this. So, we're going to this is like a bonus episode, I guess. So, we're going to be adding Ganymede in today, and if you didn't know, it's about 1 million miles away from Jupiter, so yeah, let's do that. So it's about, okay, is it? Yeah, million's about this number here, so about there. So this is how far Ganymede is from Jupiter. So if you didn't know, also it's the largest moon, like I just said. So if we compare it to Mercury, which is the smallest planet, as you can see, it is actually smaller than Ganymede, and it's also a little larger than Saturn's moon Titan as well. As you can see, Titan would fit in there. It's only the atmosphere that makes it look actually bigger. But yeah, enough of that. Let's turn this bad boy into a star. Alright, so let's turn off trails, I don't want to see that. And there we go, got a nice view of Jupiter. So my plan for this is, we need to get it to, we don't want to make it too large, but we need to get it in a binary orbit with Jupiter, and then have a binary orbit going around the sun. So basically I want to make it in a, yeah, it needs to orbit Jupiter, and Jupiter needs to orbit it, so they're orbiting each other. And then we need to get that going around the sun. So it's kind of like Pluto and its moon Charon. So if we go over to Pluto quickly, add its moons in. So let's do that. So these guys orbit each other because they're so similar in size or mass as well that they actually orbit each other. So these are basically of the Pluto system. These are both in control, I guess. I don't really know how to explain it. Yeah, but anyways, enough of poor little Pluto. Let's go back to Jupiter. So right about here, and let's start the transformation of Ganymede into a star. So let's do this. Right, so hopefully everyone's having a good day today, and yeah, let's really see if we can get to 200 subs, because I'll be impressed. I never expected I'd get above 100, to be honest, but yeah, things are going well, so it's quite good. Oh, that just looks so pretty. In fact, let's put the graphics quality on high as well. Don't usually do this, it will be a little slower than usual, but let's do that. So quality on, or yeah, textures on high, there we go, it looks way better like that. And just look at that, see the particles just look way nicer. Let's get rid of that escaping Pluto, we don't want that. Alright, so let's throw some moons in. See, look, that's how big it is compared to our moons. Honestly, right, our moon is not that small. We have quite a large moon, compared to the other moons in the solar system. And also, I'm planning on making a moon comparison video, because the next size comparison is not coming out for a while. So, yeah, I'm going to make a moon comparison. That should be a pretty cool video when it does release. We've still got the glitch Callisto here. I don't know why the whole thing just is black all the time. I still think they're working on a texture for Callisto, so that'll be pretty cool. Right, anyways, let's put a Titan in there as well. There we go. Let's throw a few Titans in. Right, we don't want Ganymede to get eaten up by any of them, so we've got to be careful how many we put in at once. Let's put some Europas in, because they obviously contain water. Another moon of Jupiter, if you didn't know. Alright, so now let's just spam it and put loads in. Right, now we can probably put more Ganymedes in, yeah, because this is getting larger and larger. Soon we'll get to about the size of Mars, because Mars is the next object in size up from Ganymede, so there's Mars. Here's Mars. Oh, we can already eat Mars. Okay, interesting. Whoa! Okay, I don't know what just happened there, but we can definitely eat an Earth now. Yeah, look at that. I have no idea how it suddenly just popped up large like that. That's pretty weird. Alright, anyways. Yeah, so I've got to be careful not to make it too hot, otherwise it will vaporize. So, yeah, we've got to be careful on the temperature there. If it gets above 10,000, I'll definitely make... Oh, excuse me there. I'll definitely make it a lot cooler, because we do not want it overheating, because that wouldn't be good. Alright. Oh, we can probably eat some of the Kepler planets here now. Yeah, easily. Alright. So let's just spam on the inside. Oh, just pop even bigger again. Alright. Getting a little large now. Right, are we larger than Uranus or Neptune yet? Nope, not yet. What about Planet 9? Okay, I don't want to put a Planet 9 in there. It looks a little risky. Alright, let's continue to put... okay, not Gliese either. Alright. Let's continue to put some more Kepler planets in there. We've got a lot of mass as well, Ganymede's collecting. Look at all the particles there. Alright. Wait, which one of these is the largest? I keep on forgetting. That's 10,000. 10,000. Okay, this is the largest one. 69. Kepler 69c is the largest out of these guys. Alright. So hopefully we can make it large enough that we can eventually eat a planet 9. Oh, wow, it's getting too hot. Alright, we gotta watch that out. Let's put it back down to 0. There we go. Yeah, we do not want it vaporizing. Because usually in these episodes, we usually see it where the object just disappears. And I don't know why that is, but someone said it could be to do with it being too hot. Wait, is that ice there? Wait, is that water or ice? These white patches here. Wait, if I remove the water quick. I don't know what those white patches are there for. Anyone know what that is? Yeah, why are there white patches? Usually when an object's this hot. Oh, I know why. Because we put it down to 0, but the surface is still molten. That's basically like a little game bug. Like if we let time speed up, I'm pretty sure more water should appear. Okay, we're not getting. Okay, we're getting too close to Jupiter. We need to make it auto orbit again. All right. Okay, good. Yeah, we do not want this crashing into Jupiter because that wouldn't be too good. In fact, let's move it a lot further out. Okay, it's got a lot closer. Let's put a 0 on the end of this. Okay, so now we're 4 million miles. We're 4 times further than Ganymede was originally. Because we obviously don't want it too close because it could tear up Jupiter because of mass, or they could collide, and yeah, that wouldn't be good. Alright, we can probably eat a Uranus now. Oh, that's a little risky. Okay, I'll go for a planet 9 actually. There we go. Okay, now Ganymede is a gas giant. Oh, look at that, his particle effects. That's so cool. Alright. So now let's just make Ganymede massive. Just spamming planet 9s in. Alright. Okay, I'll keep an eye on the temperature. We're already at 10,000. I just saw that. That was 10,000 there. For a brief second, then it went down. Wow, this is crazy. Okay, we're going pretty successful so far. So make sure if you like the video up to this point, make sure you hit that like button, all that stuff. Never really ask for it. It doesn't really bother me. I just like seeing comments. Yeah, so if you've got something to say or want to share your interests or ask a question, yeah, I'm sure the comment section will be the place to go, honestly. Okay, wait, we want to have Neptunes because they got more mass. We need mass. Making stuff into stars requires mass. Alright, let's reset it to 0 degrees as well. Look at all of the explosion effects. That's so cool. I just love those effects. Like, look at that. All of the different impacts are just going all across the planet at once. It's still a planet right now. So, just look at that. It looks so amazing. I should do a thumbnail of one of these, like, looking objects one day. Look at that, even from behind. That looks so nice. It looks really cool like that. And eventually it will just calm down. Let's make it so it's orbiting Jupiter still. We're probably in a binary orbit since it's got more mass than Jupiter right now. Look at all of the gases are all smudged. That's really nice. Just looks so like cool. Like that blue line, you see that it like drips down here and it goes back up here. If you can just see that, that's very strange. It's very cool. Let's try a few more Earths in. Why not? All right. So can we wait? What about Saturn? Okay, we still can't eat a Saturn yet. So what if we have a little play around in the menu here? So what if we do this? Turn that off and turn it on again. Okay, so it doesn't change the size. Okay, I guess it's not very dense, or it's a little more dense, so that's why it's smaller. Because it has more mass than Jupiter, but it's still smaller. It's yeah, about 2/3 the size of Jupiter there. So that's interesting. All right, let's continue to throw some more Uranuses and Neptunes in. Oh yeah, Neptune. Yeah, Neptune. All right. Not because it's my favorite planet, because it does have more mass. If you look right here, mass of 17.1 Earths, but Uranus has a mass of 14. Yeah, 14.5. Oh, look how it's spinning pretty fast. Okay, 50,000. We definitely don't want that. Okay, now it's gone blue. Please, go back to 0. Okay. It's spinning really quick. 11-minute daytime. That's pretty crazy. Alright. Okay, I don't really think we can do much about the heat there, but let's continue to throw these guys in. Look how we look at the Neptune ring just like fall into it. That's like so cool. I'll never get unsatisfied with this game, or Sandbox I guess, but I just love this simulator so much. Yeah, tell me, how many of you guys actually have this game or simulator as well? Like, yeah, tell me in the comments. So see how many people actually have this. Alright, it is quite, I guess it's not the most cheap thing in the world. It's like £20, I'm in the UK or England, so yeah, it's in pounds, but I think it's like $22 I want to say. I don't know for sure. It's definitely around $20 or £20 or wherever you live. Yeah, definitely one of those. I have no idea. I don't know about the other currencies. I only really know pounds and dollars, and I guess euros as well. But yeah, I have no idea. Alright, so let's continue to spam these in. Okay, Ganymede's getting very hot. Okay, we don't want it to be at 50,000. That's almost as hot as Rigel, I think. Yeah, right here. Where's Rigel? Come on, where's that? I don't want to place it, but yeah. Yeah, this guy. Almost as hot as this star here. Okay, oh, just look at those effects. They're just so amazing. Just look at all this. It looks so nice like that. I should one day make a planet that looks like this. We should try it with Earth. That'd be cool. Alright. Yeah, these effects are just so cool. I don't even know what to call them. What should I call these? Like the impact. I'll just call it impact effects for now, or impact strikes or something. Yeah, so those impact strikes are amazing. Alright. Right, Uranus, no, Neptune. Okay, there we go. So the mass needs... Okay, we have lost mass. Okay, that's interesting. In fact, actually, let's speed things up, because we aren't really advanced. Let's go up to... Let's go to 30 Jupiters. There we go. Okay, we've got to make sure we're not, like... gonna pull... We don't want to pull Jupiter in. So we are larger than Jupiter now. Look, if we go to Jupiter, and say we go on the north here. So, as you can see, that's pretty large. So, if you want to get a quick comparison as well, there it is compared to the other planets and the Sun. So, yeah, that's quite large. We're almost the size of the largest exoplanet, I want to say. No, we're definitely nowhere near it. You're right. If you want to see the largest exoplanet, then you're going to see some serious stuff, because this thing is huge. Yeah, that's the largest planet, we think. It may be a brown dwarf, but we don't know for sure, I believe. Alright. So let's hit play, and... Okay, let's speed up to 100. Let's actually just turn it straight into a star. Okay. So there we go. Okay, so Ganymede is now a blue star, which is interesting. Alright, now let's put it in a orbit with Jupiter. Or Jupiter in orbit of it, actually. Okay, there we go. So now Jupiter should be in a good orbit. Let's quickly get rid of all this dust as well. Control and D if you didn't know, to get rid of any particles. So we have a massive 100 Jupiters. So this thing's barely a star, I believe. Right, anyways. Okay, let's make its luminosity... Okay, so wait, if we just have a quick look at the Sun. Try and make it a little realistic. So the Sun is 1,000 Jupiters. So if this is only 100 Jupiters, then if we see the luminosity of the Sun is 1, so because this is 10 times like less in mass, I guess we make the luminosity 10 times less as well. So let's make the luminosity 0.1 of the Sun there. So L Sun. I don't know why it's called L Sun, but luminosity Sun, I guess that means. Alright. So 0.1. Okay, so there we go. So now Jupiter should be more. So if we go to Jupiter, as you can see, we got a very close star right now. This shouldn't emit too much heat as well, since it's not really the brightest of stars. But anyways, let's add these aren't going to be accurate, like, but let's add Io, Europa, and Callisto in. So let's add Io about there. I don't know these values, so don't blame me. Oh, they're getting vaporized. Okay, so Europa would be... Okay, it's just going to get stolen by the star, but let's do it anyway. And then Callisto, let's get the Callisto. And let's put it about here. And I don't know how far, if these are accurate or not, obviously, but yeah, we'll just live with it like that. So we've got the rest of Jupiter's moons, and they're getting vaporized by the very, very large Ganymede now. Okay, so as you can see there, this isn't Jupiter tearing it up, this is the star. How hot is it getting as well? 300 degrees already. I don't know if it's usually that hot, I think it's usually cold. Yeah, Europa's going to get taken out. See all this material it's losing here, that is the water, because... Yeah, as you can see here, this right now, 14.9% of the entire object is water or ice. So that's pretty cool. One day we may be able to actually like set a base here. They think there's a they actually think there could be like life here that exists like deep below, because they think there's warm water like deep below this moon here. And also, one interesting fact, if you remember the Galileo spacecraft, which was around here in the 80s and 90s, I think, I don't know the precise date, but they crashed it into Jupiter because they didn't want it to contaminate this moon, because obviously, like, if you didn't know, bacteria, no matter what, bacteria will always get on spacecraft from Earth. Like, it's not like bad, it's like, I think it's friendly bacteria. Someone correct me on that if I'm wrong, but the bacteria gets on the space probe, and if they crash the space probe on the moon, some like bacteria cells or something, yeah, something to do with life would like start living here, or like start like colonizing it almost, like, and the scientists didn't want that, so they avoided it by crashing it into Jupiter. So typically we have contaminated Jupiter multiple times because we've thrown a probe in it before, and then the Galileo probe shot a little probe into it, and then Galileo, I believe they crashed it in there as well. So we have contaminated like 0.0000 a lot of zeros, and then 1 like percent of the entire mass of Jupiter. So yeah, we have thrown something in here, so we have sort of contaminated the largest planet, I guess. Very, very small, like very, very small amount of contamination, like considerably tiny, but we have still done it. But anyways, enough of me babbling on about stuff I don't 100% know about. As we can see here, Callisto, Io, Europa are all getting vaporized right now. Well, those two are like smoking up, but this one is just losing its water, so that's interesting. Right, anyways, let's check the orbits of the whole solar system now. So, Okay, so we currently have a binary orbit with the sun, and obviously Jupiter can't even be in a binary orbit with it because the sun is like the next object in size up. So yeah, Jupiter is now in orbit of Ganymede, and Ganymede is now in a binary orbit of the sun. So this is what actually, well, it wasn't exactly what I wanted, but yeah, this is close enough. This is good. Okay, so Callisto and Europa are now orbiting Ganymede, because obviously Ganymede's 100 times stronger than Jupiter is at like holding objects now, pretty much. So let's see what it's like on Earth to have two suns right now. So let's go land here. Okay, oh, there's the UK where I am right there. Let's land in the UK. Try and land in somewhere near. Okay, we're in France. Okay, that's close enough. All right. So if we turn off the orbits, can we see Jupiter? Let's have a look. Wait, is it down here? Wait, where is it? Oh, where's Ganymede? Please? Where is it? Okay, that obviously didn't work. Okay, let's just go to the North Pole, because we should be able to see easier from here. Oh wait, where is it? Oh, here's the North. Alright. Oh yeah, I forgot the North isn't even the highest point. Okay, the highest point is about here. Okay, now we should be able to see it now. Okay, there it is. So let's quickly delete the smoke or the particles. As you can see, Ganymede is very small actually. Just looks like any other star in the sky, but even though it is small, its light is still reaching Earth, so that's good to know. Like if we compare it to the sun in the sky, it's tiny. In fact, let's actually get a whole comparison of sizes here. So it's not that large, honestly, Ganymede. It's probably about similar size to Proxima, actually. So that's one of the small red dwarf stars. So I still don't know why it's blue. That's interesting why it is blue, but that's obviously it's quite hot. Maybe it's just because of the impacts from earlier, but honestly, I don't know. Okay, that's a lot bigger than Proxima, actually. Alright. Is it? What about Alpha Centauri B, which is a smaller one? Because we've got Alpha Centauri A and B. A is... Okay, it's a lot smaller. Okay, A is larger than the sun, but B is a little smaller. Okay, I don't know. I don't really know what class they put this star in, honestly. Yeah, what about Wolf? Okay, it's a lot larger than Wolf. It's a lot larger than Proxima. Okay, I don't know what sort of star this would be. I'm assuming if it was realistic, it would be more of a red dwarf star, but we'll just leave it blue because it does look pretty cool. Alright, so let's go play again, and now we want to speed up time a lot more. So I'm probably gonna think. Actually, no, because if you've seen the previous episodes, I'll leave like a little picture for you to click on at the end or tap on or whatever device you're on. So usually when we make something into a star, like for instance Saturn, which is last episode, it basically stole the Earth from the Sun, and the Earth started orbiting Saturn for a brief time. But now, because Ganymede doesn't have as much mass of the Sun, as we can see, it should have about 10%. Oh, it's got 9.5 for some reason. Yeah, about 10% of the Sun. It's not strong enough to pull the Earth away. So nothing really should happen to Earth. I don't know why it's hotter than usual. That isn't right. Let's put the climate on. Okay, so 29. Okay, that's interesting why it's at 30, because the luminosity of this star shouldn't really affect the Earth, I want to say. It will heat it up at night time a little more, but still. Okay, I don't know why that is. Because it's less luminous than the Sun, but it's making Earth warmer than usual. That could just be a glitch, though, so if anyone knows why, please tell me. Right, anyways, let's speed up time a lot more. Okay, so we've got a blue orbit. It looks like the Planet 9 orbit, actually. And for once, in one of these episodes, Planet 9 and Sedna are still actually orbiting the Sun for a change, rather than breaking away, so that's a first. Alright, but I bet you if we speed up time, we will lose them eventually. Okay, so the orbits are changing. Okay, now... Yeah, that's smoke over there. We may want to remove the moons, because it looks like it will completely slow the PC down. See, no matter how good your PC is, it will never be able to run this game. Alright, so let's just pretend they vaporized, because they probably would eventually. Like, they are smoking, they are losing lots of material. So, yeah, they probably would vaporize eventually. And let's get rid of Io as well. Where's Io? There it is. Most volcanic moon in the solar system. And also, this is the most geologically active body in the solar system. This thing has like more volcanic eruptions than Earth does. Like, this whole object is volcanoes. Like, you see all these dots here? These are probably all volcanoes. Like, if we zoom in on these ones here, even on the highest graphics quality, yeah, those are probably volcanoes. I don't know like the map surface of Io, so yeah, don't quote me on that or judge me on that. Right, there we go. So that's all gone. So now the simulation should run a lot more easy. Okay, so let's hit play, and yeah, that's better. All right, so. Okay, we get a little more lag than usual. That's interesting. Probably because Jupiter's orbiting Ganymede. In fact, yeah, let's put the graphics quality on low as well, because that will help out. Right, there we go. Let's put it on low, because we're not really zooming into any objects now. And let's also remove... Wait, what was I going to do? Oh, let's turn off the climate on Earth, because sometimes the climate, when it's on, it slows the game down more. Because, like, it's simulating, like, the snow and, like, poles on Earth, North and South Pole. So that can also increase, like, game lag, which isn't good. Alright, so let's speed it up a lot more. Yeah, sorry about the lag, but you can't really do anything about it. Okay, so I'm just looking on the recording system right now. So, yeah, it's running fine. Well, it's been worse. Just, yeah, if you've seen, like, the one where I made a whole solar system out of asteroids, yeah, that was, like, probably the most laggy episode I've ever recorded of any game on my channel. Like, it was ridiculous. In fact, actually, to make things more useful as well, for a change, let's actually remove some of these dwarf planets, because, honestly, they're so insignificant that nothing would really happen. So, yeah, we'll just keep, like, the well-known ones. So we'll keep Make, Iris there. Let's get rid of this one as well. We'll obviously keep Cedar and Planet 9, because, yeah, they're awesome, but, yeah. Let's get rid of, poor old Charlicchio is here. I can never say that one. Alright, there we go. And if you're wondering how I got it to an orange colour like that, what I did was I turned it into a star, then turned it down again into an asteroid, because it keeps the colour. So that's what I did with Cedar and Planet 9. These were once stars at one point, and then I, like, turned them back to planets again, and that's why they kept these colours, because usually in a randomly generated one, they just sound like random colour. So, like, if I just, for instance, let's just get a random gas giant. They just spawn these random colours. Okay, and I do not want that gas giant there. So, get out of here. Alright, there we go. Oh, I forgot the moons of Pluto was still here as well. So, yeah, just bear with me here. Sorry if this is holding you up. But, yeah. Hydra, Charon. Okay, there we go. I think that's all of them. It looks like one of the Pluto moons disappeared, actually. Okay, there we go. That's good enough. Alright, so anyways, back to what we were doing. It's hit play, and yeah, that's a lot better. That's a lot better. Okay. So, this is a crazy... What is going on right now? Saturn's like... It's interrupting with Saturn a bit. Okay, it's Jupiter's... Okay, Jupiter's still in a perfect orbit. It is very... Wow, Jupiter is very hot. That can almost compete with Mercury's temperature, I want to say. Well, what about Venus? Oh, Jupiter is now the new hottest planet in the solar system by... How much was that? Wait, Venus. 93. So Jupiter is 6 degrees hotter than Venus as of that point there. So, new hottest planet in the solar system. Well, it goes up to 400 as well. Okay, interesting. Because if we quickly look at Jupiter's stats as well, if we go in here, Jupiter reflects 34% of the light it receives. So 66% of light it receives, it actually absorbs. So that's quite a lot. If we compare it to Venus here, Venus reflects 88% of light, but it still has a heavy atmosphere. That's why it's so hot. So if we just do that, go up here. So Earth's orbit has changed actually. So for once it's actually colder rather than hot. Oh, I need a quick drink. Please excuse me. That's better. Okay, so Earth is getting really hot and really cold. So obviously when it gets... Oh, it's because Ganymede's moving in. Ganymede's getting closer as well. So if Ganymede gets to this point here, you see in between Earth and Venus's orbit here, if it gets there when Earth and Venus are in those areas, it could steal them from the sun. It could just take them away from the sun. And then they'll probably get, like, thrown out here. Or Jupiter could, like, eject them. Because if we had a gas giant in, like, the close to the sun, it probably would eject Mercury and Venus, maybe. And probably Earth as well. It would definitely ruin the orbits. But as you can see that as Ganymede moved inwards there, it really messed up Ceres' orbit there. And obviously the other planets as well. So put Ceres here, which is now a dwarf planet, I believe. So I think at one point they class it as an asteroid. But yeah, this is now, I'm pretty sure this is officially a dwarf planet. So yeah, someone tell me that as well. Yeah, Ceres is, I'm pretty sure it is a dwarf planet. Because at one point I thought, wait, is it an asteroid or is it a dwarf planet? Because it is in the asteroid belt and it is very small. But it is still circular, so yeah, it's a dwarf planet. Like, I'm pretty sure it is anyway. So yeah, someone tell me that. I'm pretty sure Ceres is. Alright, anyways. So keeping up. How's Mars doing? We haven't checked up on Mars. Minus 63. Okay, so it's getting a little colder than usual, I want to say. I think Mars is usually minus 57, so yeah, that's good to know. Anything else with the other planets? Okay, Uranus, Neptune, Pluto, Iris, make their orbits have changed. Sedna is not even in orbit right now, and Planet 9 is barely hanging on, probably. Okay, we are still playing, alright. Okay, let's speed up again. Let's see what happens next. Okay, I really want to see what happens if Ganymede moves inwards next to the sun there, where Venus is right now. I reckon it will take Earth and Venus away. Probably not Mercury, because if you've seen these episodes, Mercury always stays around the sun. Okay, wow, look how much that energy it's, like, releasing. That's pretty weird. 17,000 degrees, or 18,000 there. Wow. That is very hot. Half of the scene just went to supernova right now, because that would suck. But anyways, so any more trouble it's causing system? The binary orbit here is very weird. It's probably because it looks like Ganymede is orbiting the sun more than the sun is orbiting Ganymede, because Ganymede is definitely moving a lot faster than the sun. So if we look at the sun, millisecond or meters a second, but this one is moving at kilometers a second. So yeah, Ganymede is moving a lot faster than the sun is. But look at this. Oh yeah, there it is. It just, if you just saw that brief point there, go back a few seconds on the video there, you just saw that Earth was in orbit of Ganymede for a brief time. Oh, we've lost Venus. Venus has gone. And Venus is cooling down now. So we have lost Venus. That's not good. Uranus's orbit is going crazy. It just reset there. That's crazy. Planet 9 and Saturn are still in orbit. That is very interesting, because usually they don't do that. Their orbits are very, very like corrupted right now. But yeah, they are still moving. So yeah, we have lost poor Venus. Don't know about Neptune and Eris there. I don't know why my voice is hurting. That's weird. I need to have a drink. Please excuse me again. I have to end the video soon, but I don't know why that is. My voice is like excuse me again, but yeah, don't know why that is. Obviously if I talk for too long it just breaks my voice, I guess, but you know, I think I'll talk a little lower, so yeah, sorry if you can't hear me as much, but I prefer to save my voice, I guess. Alright, so let's speed it up a lot more. Okay, so we've lost Mars as well. So how's Earth doing? Earth's probably frozen right now. Yeah, minus 120, so yeah, this is very cold. But the cities are still there. All of the lights are still lit up. So that's strange. Because at minus 123, I'm pretty sure humanity wouldn't be able to survive unless central heating in like your houses was like working perfectly. But in some places, for instance Australia, where they don't have central heating because it's hot all year, they would probably die out very quickly. Sorry to anyone who's Australian, but I guess that's a fact. Like, I'm pretty sure you guys don't have like heating in your houses like we do in the UK, or say like in Canada, or like high up in Russia. I guess like anywhere without central heating would like die out but pretty quick. But on these anyways, the whole world would be suffering anyway, so yeah, none of these lights would probably be on. Anyway, enough of me just talking about that. I don't know what I'm talking about. Alright, anyways, let's speed up time again. Yeah, what am I even saying? That? Yeah, no offense to anyone. It's just me babbling on. Don't take any offense. Don't take what I'm doing seriously. Alright, so Planet 9 is still holding on. That's good. Sedna's hanging on as well. So we've definitely lost Venus and Mars. They're gone. Okay, so let's see what happens when Ganymede moves back in again. Oh, where's Earth? Where'd Earth go? We lost. Oh, we've lost Earth as well. It's getting close on Uranus right now. Can we see Uranus from Earth? Is it? Or is it too far away? We can faintly see. Wait, can we see? No, we can't. I can't see any blue dot there. So yeah, Earth is gone. There is a little cool feature if you didn't know about. Where is it? It's somewhere. Yeah, there's a secret option where you can like turn on something. Is it power? I think it's power. Where is it? There is definitely like a secret menu somewhere where you can do. Yeah, here it is. Icons. Now we can see like the dots of everything. So that's pretty cool. Little cool feature you didn't know. So you go on view and you press this show more option and you turn the icons on. And you can see there's Uranus. It's just a blue dot now. So it's a little way to spot your planets if you didn't know. And the sun's got like a cool little sun around it. Okay, I think I'll leave this on for this episode. Why not? So as you can see, Jupiter is right next to it as well. If you zoom out, the sun will still be the most speed one. But yeah, it's a cool feature. If you don't want the labels on, or you don't want the trails or like orbits or anything, you can see the or planets still. So is this Mercury here? So how's Mercury? We haven't checked up on Mercury. Yeah, so Mercury's literally just doing normal. Like its orbit's barely changed. It's pretty much exactly the same. But we have lost all of the other inner planets. So is this Ceres here? Yeah, Ceres and Vesta. Yeah, that's Vesta. Where's Vesta? Let's put labels on again. Where is it? Where is Vesta? Oh, there it is. So Ceres and Vesta, these guys are still doing the same. In most episodes, these guys always pretty much stay the same. They don't usually get ejected. So you see poor old Mars has gone there. But now, let's speed up time a lot more. And let's see what craziness can unfold here. So this was a very interesting episode. Thank you for the 2 people who commented on Ganymede. So there was definitely 2 of you. Know that. Don't know if there was a 3rd one. There may have been one on another video way back, but I can't remember honestly. There was definitely 2 of you. So many thanks to your video idea. See, if there's an idea I really like, I'll make a video on it pretty quickly. And there was a guy about the TRAPPIST-1 system where I should trade the planets for like our inner planets. Don't worry, I will be making a video on that soon. Alright, but anyways, so let's check it out. So we've definitely lost these guys, so we can delete Venus and Mars. Venus, come on, select it. Venus, Mars, we've definitely lost Earth. Come on, delete Earth, come on. And there we go. Okay, so let's see what's going to happen next. So, this is just insane, like, I'm still really surprised Planet 9 and Sedna are still hanging on right now, because usually they just get thrown off in completely different directions there. Oh, my voice is aching again. Oh, God. I can't really handle much more of this, guys. Yeah, please excuse me, as I said before, but, yeah, there we go. I'll grab a little more water, actually. Yeah, I can't really cut the videos right now, so I'm still learning how to, like, edit and stuff. I'm not really the best. I'm quite good with my thumbnails, so, yeah. But anyways. Okay, so it looks like the Sun and Ganymede are a lot better, like, orbits right now. Let's check the trails. Let's see how they're doing. So, yeah, the Sun, yeah, so Ganymede is the one that's spinning out and then coming backwards, which pulls the Sun like this. Yeah, so Ganymede is definitely the weaker of the two, obviously, because the Sun's got a lot more mass and size. We've got a little close up from Saturn there. So that's pretty crazy. The orbits have just gone mad right now. Yeah, but like I said, a very, very interesting episode. And how did Sedna get all the way out here? Sedna's very far away right now. This is usually in the asteroid belt, not the Kuiper belt, which is, if you didn't know, that's the asteroid belt that's further away than the Sun than Neptune is. And Ceres as well. It's where it belongs, in like much further out territory in where all the other dwarf planets are. Because if you didn't know, Ceres is the only dwarf planet in the asteroid belt to our knowledge. So yeah, that's pretty interesting. Alright, anyways. So I think we're just... God, wow, my voice is really killing me. Oh my god. Yeah, but I think that should conclude the episode soon, because honestly, not much else is happening right now. We can speed up time like to tons of months a second, but honestly, the orbits are changing a bit. Nothing else right now is getting ejected. So I guess would you call this a stable solar system? Like, I guess it's not really stable because the orbits keep on changing, but these objects are not getting ejected. So would you call that stable or not? Like, I don't know about that. Well, obviously Mercury around the Sun, that's definitely stable. And then Jupiter around Ganymede, that's also stable. Wait, I want to quickly see this Saturn flyby, actually. Let's slow down time. Let's hit play. Now, Saturn. Let's keep an eye on Saturn here, quickly. So, as you see right now, Saturn's orbit is continually changing. I think that is because Jupiter, if we just zoom on Ganymede here, you see the dot there. Jupiter is the one that's causing Saturn's orbit to do this right now. So even though Ganymede's got mass, Jupiter's mass still exists, and it still is causing issues for Saturn right now. Because Saturn obviously has a lot of mass. Like if we compare it to the mass of Jupiter, Saturn's mass is only 29% of the mass of Jupiter. So yeah, it's pretty small. But anyways. Oh, the orbit's changed again. Okay. So you can see some of these orbits have like changed into circles again. Wow, this is crazy though. Okay, we'll speed it up a lot more, so we'll definitely get some like good footage here, but I think that should be it for this episode, because we're not really getting much else now. Because usually we get a few planets ejected and then that's it. But we got a lot more, actually, than usual. A lot more interest in this. Because you may think, oh, when you see these episodes, oh, it's just the same thing over and over again, just a different planet. But honestly, we get some real different outcomes when we turn planets or an object into a star. Today it was a moon, obviously. We've obviously done the moon before, but yeah, this is the second ever moon I've done, which is Ganymede, obviously. Wow, Jupiter's spinning around there really quick. How much is 1 day or 1 year on Jupiter now? Let's have a look. Where is it? 9.91 hours. That hasn't really changed. Okay, so it takes 10 days to go around Ganymede with Jupiter right now. So if you want to have a little peek about what a day on Jupiter would be like, be my guest. Let's have a look. Alright, so if we land on the surface. And that's good. I can have a quick drink while you're watching this. So yeah, let's do that. Wow, that looks really nice. Have a little glimpse at the sun there. You can see the other planets, these dots right here. There we go. There's one there. Is that one there? That's definitely Mercury. Oh yeah, because the other one's a lot further out. Well, there's Andromeda there. If you have a little peek, Andromeda Galaxy. Alright, so where is it right now? Ganymede, where are you? Okay, we see a planet coming up on the horizon there. That is Saturn. We've got Sedna as well. Oh, here we go. Here's your sunrise. Oh, look at that. Looks nice. Wow. So that's pretty close. It'd be pretty cool to live around a blue star, but it would be a lot more dangerous because I believe they emit a lot of radiation and different types of radiation compared to the sun as well. Oh, Jupiter's heating up. You see those some of the gases have gone orange there. Right, anyways. So let's go out again. So you've got a nice sunrise. Okay, so yeah, these orbits aren't changed anymore. No objects got ejected recently. Everyone's still like staying in the same areas. If we go to the orbit or the trails here, yeah, nothing's really changing. They're still in orbit of the two central objects, which is obviously the Sun and Ganymede here. And so I think to end this off, we'll have Jupiter collide with Ganymede and the Mercury collide with the Sun. So we'll put it in, yeah, a few minutes a second, and we will slowly decrease Jupiter's orbit. So here we go. It's going down. So it's going to get hotter as well. As you can see, it's burning up right now. Let's put it really close so it becomes like a complete inferno on this planet right now. So it's getting closer. We're about 600. Is that 600? Is that 6 million? Oh, it's being torn up. Oh, we're going to have a new ring system around Ganymede. So the largest planet in the solar system is being torn up by its largest moon. Oh, it's just being vaporized. Oh my god. Wow, Ganymede, what have you done? Look at it, it's just turned into dust. We had this huge gas giant just being vaporized. Let's add another one in. Like, look, ready? It's being torn up. Oh no. Well, poor old Jupiter's gone. In fact, let's have a little fun show, I guess. Let's have a Jupiter ring show. So we're gonna get lots of fiery hot Jupiters get just vaporized and turn into rings. There we go. Let's watch this. So they may be colliding, but they're still going to get torn up. And some of them may hit the star. Oh, they're going in. Oh, they destroyed it. They ruined Ganymede. Oh my god. What is going on? So the Ganymede star has been destroyed. But in fact, let's turn it back up to a star. So there we go. Oh, it's a yellow star now. Okay. Oh, it's gone crazy. Okay, let's put it to 200 Jupiters so it doesn't like lose its mass all the time. That is pretty cool. Look at all these blue particles. These are all... Or some of this is probably from the star itself, honestly. Oh, we've lost Ganymede. It turned into a fragment. Okay, that's interesting. So the Ganymede is no more. So, yeah, that part of the solar system has been destroyed. Now the Sun and Mercury. Yeah, I don't think much is going to happen here, but still worth it. Why not? Okay, so we're on Mercury right now. You see all the carnage over there. Alright, so let's just destroy Mercury's orbit. So 55 million miles, I think that was. So, or was it billion? I don't know. Anyways, let's get closer and closer. So Mercury's temperature is going to heat up. As we can see here, look at its temperature gauge. Keep an eye on the temperature gauge. So it's 400 degrees, so it's getting hotter than Venus now. Getting closer to the sun, because remember the sun is hotter and more bright than Ganymede was. So yeah, it's going to be a lot more crazy. Eventually, if we get too close, Mercury will start being destroyed like Jupiter was. So let's get... Okay, we're getting really close now. Oh wow, that is very close. Oh, and it just bashed into the sun. Well, poor Mercury. Got a bit of the trail just falling out into space right now. The remains of Mercury. And that's that. Anyway, should we supernova the sun? Can we do that? Please? I thought there was an option to do it. Oh well. Right, in fact, let's collide the sun with the sun to end this solar system. This is a pretty fun episode, actually. If you want to have a final look at what's left. There you go. So our remaining objects are... Obviously, Ganymede and Jupiter were before I destroyed them. We've got this fragment now. Okay, we've got a ton of Jupiters. We've got, obviously, got Saturn. We've got Uranus, Neptune, Planet 9, obviously, and then we've got these remaining objects down here. So we've got Pluto, Eris, that's Make there, Ceres, and Vesta. So they're our remaining objects. And wait, are these black holes? Oh, no, they're not. They're just fragments. Okay, I thought they were black holes for a second. I was like, hang on, how did they get that much matter to become a black hole anyway? Anyways, well, these are orbs in the sun now. Wow. All right. Yeah, they must be very hot. Anyway, let's put a sun into the sun, and boom, that's it. It's over. In fact, let's do it with our other fragment star as well. What's left of Ganymede? So let's do that as well. Right, supernova, come on, go. There we go, and it's over. Poor solar system. Everything's gonna get vaporized now, or it should do anyway. Okay, speed up time, and watch as these two supernovas just decimate all of the remaining objects. So Planet 9. I wonder if Planet 9 will survive or not. So let's speed this up. So yeah, guys, hopefully you will enjoy this episode. And let's see, can we get to 200 subs before the end of the month? So we have 8 days. So we're currently at 187. So we need 13 more. So can we do it? So yeah, and there may be a special Universe Sandbox episode once we get to 200 subs as well. So it'll be a two-parter. So I have two of your requests in the same episode. So yeah, we get to 200 before the end of the month. On the first day of the next month. Wait, what? Okay, first day of April. I almost forgot my months there. First day of April, or whenever I next make a video, I'll say which 2 ideas I like the most, or something like that. I don't know. We'll get around it when I do it. Right. Anyways, so let's speed up and watches all the objects just leave where the solar system used to be. Oh, Planet 9 survived. Okay. Even Sedna survived the supernovas. Okay, very interesting. Okay. So let's zoom in here and see what our main objects. We got the fragments which were from the Jupiter and Ganymede collision. So Planet 9. What's this? Jupiter. Why is it all blacked out like that? That's weird. So we got a Jupiter. Got Neptune. Whoa! Neptune and Uranus. That's all that's left. They lost all of their gas. Neptune, Uranus, Sedna. No way that's Saturn. Oh my... How did it get that small? 102 No way. That is crap. I've never had... This is glitched as well, because Saturn shouldn't be this big. Like, if an object gets that small, its texture should, like, all corrupt. Not like... Wait, it should be like this... Oh, wait. Asteroid. Yeah, it should be like this. The texture... It should look like... Wait, slow down. Let's pause it. It should look like this. I don't know why Saturn's, like, glitched like that. Well, cool glitch. So we found a custom-looking Saturn there. So that's pretty sweet. I won't save it, though. It's no use to me. But so we've got a glitched-out Saturn there. And obviously... Yeah, that's that. So if we have another look, there's our remaining objects. So we've got these... The Jupiters are glitched out as well. That's very cool. And then Uranus and Neptune lost their gas. Planet 9 survived because it's a lot further away. But anyways, that should be that. So, yeah, as we watch this supernova just explode out, hopefully, like, you guys really enjoyed this video. Cause, yeah, this was quite a fun one to make, actually. I really enjoyed this. So, yeah, if you liked it, make sure you hit that like button, subscribe to see if we can get to our 200 subs goal for the end of the month. And, yeah, have a good day. And, yeah, see you in the next video. Goodbye. I guess. So, we're going to be adding Ganymede in today, and if you didn't know, it's about 1 million miles away from Jupiter, so, yeah, let's do that. So, it's about, okay, is it, yeah, 1 million's about this number here, so about there. So, this is how far Ganymede is from Jupiter. So, if you didn't know, also, it's the largest moon, like I just said. So, if we compare it to Mercury, which is the smallest planet, as you can see, it is actually smaller than Ganymede, and it's also a little larger than Saturn's moon Titan as well. As you can see, Titan would fit in there. It's only the atmosphere that makes it look actually bigger. But yeah, enough of that. Let's turn this bad boy into a star. Alright, so let's turn off trail, so I don't want to see that. And there we go, got a nice view of Jupiter. So my plan for this is, we need to get it to, we don't want to make it too large, but we need to get it in a binary orbit with Jupiter, and then have a binary orbit going around the sun. So basically I want to make it in a, yeah, it needs to orbit Jupiter, and Jupiter needs to orbit it, so they're orbiting each other. And then we need to get that going around the sun. So it's kind of like Pluto and its moon Charon. So if we go over to Pluto quickly, add its moons in. So let's do that. So these guys orbit each other because they're so similar in size. Or we've got the glitch Callisto here. I don't know why the whole thing just is black all the time. I still think they're working on a texture for Callisto, so that'll be pretty cool. Right, anyways, let's put a Titan in there as well. There we go. Let's throw a few Titans in. Right, we don't want Ganymede to get eaten up by any of them, so we've got to be careful how many we put in at once. Let's put some Europas in, because they obviously contain water. Another moon of Jupiter, if you didn't know. Alright, so now let's just spam it and put loads in. Right, now we can probably put more Ganymedes in, yeah, because this is getting larger and larger. Soon we'll get to be about the size of Mars, because Mars is the next object in size up from Ganymede. So, there's Mars. Here's Mars. Oh, we can already eat Mars. Okay, interesting. Whoa! Okay, I don't know what just happened there, but we can definitely eat an Earth now. Yeah, look at that. I have no idea how it suddenly just popped up like large like that. That's pretty weird. Alright, anyways. Yeah, so I've got to be careful not to make it too hot, otherwise it will vaporize. So, yeah, we've got to be careful on the temperature there. If it gets above 10,000, I'll definitely make... Oh, excuse me there. I'll definitely make it a lot cooler, because we do not want it overheating, because that wouldn't be good. Alright. Oh, we can probably eat some of the Kepler planets here now. Yeah, easily. Alright. So let's just spam on the inside. Oh, just pop even bigger again. Right, getting a little large now. Right, are we larger than Uranus or Neptune yet? Nope, not yet. What about Planet 9? Okay, I don't want to put a Planet 9 in there. It looks a little risky. Alright, let's continue to put... okay, not Gliese either. Alright, let's continue to put some more Kepler planets in there. We've got a lot of mass as well, Ganymede's collecting. Look at all the particles there. Alright. Wait, which one of these is the largest? I keep on forgetting. So that's 10,000... 10,000. Okay, this is the largest one. 69. Kepler 69c is the largest out of these guys. Alright. So hopefully we can make it large enough that we can eventually eat a planet 9. Oh, wow, it's getting too hot. Alright, we gotta watch that out. Let's put it back down to 0. There we go. Yeah, we do not want it vaporizing. Because usually in these episodes, we usually see it where the object just disappears. And I don't know why that is, but someone said it could be to do with it being too hot. Wait, is that ice there? Wait, is that water or ice? These white patches here. Wait, if I remove the water quick. I don't know what those white patches are there for. Anyone know what that is? Yeah, why are the white patches? Usually when an object's this hot. Oh, I know why. Because we put it down mass as well. That they actually orbit each other. So these are basically of the Pluto system. These are like both like in control, I guess. I don't really know how to explain it. Yeah, but anyways, enough of poor little Pluto. Let's go back to Jupiter. So right about here. And let's start the transformation of Ganymede into a star. So let's do this. Right, so hopefully everyone's having a good day today, and yeah, let's really see if we can get to 200 subs, because I'll be impressed. I never expected I'd get above 100, to be honest, but yeah, things are going well, so it's quite good. Oh, that just looks so pretty. In fact, let's put the graphics quality on high as well. Don't usually do this, it will be a little slower than usual, but let's do that. So quality on, or yeah, textures on high, there we go, it looks way better like that. And just look at that, see the particles just look way nicer. Let's get rid of that escaping Pluto, we don't want that. Alright, so let's throw some moons in. See, look, that's how big it is compared to our moons. Honestly, right, our moon is not that small. We have quite a large moon, like, compared to the other moons in the solar system. And also, I'm planning on making a moon comparison video, because the next size comparison is not coming out for a while. So, yeah, I'm going to make a moon comparison. That should be a pretty cool video when it does release. We still... Hello everyone, and welcome back to another Universe Sandbox 2 video. Now today, before I get into what we are doing, I've got a little challenge for you guys watching the video. So currently we're at 187 subscribers, but I've got a little challenge. So can we get to 200 before the end of the month? So right now we have 8 days till the end of the month as of recording this. So can we get to 200 before the end of the month? That's my first little challenge. I've never really set a subscriber goal before, so yeah, can we do that? So make sure if you're watching right now, if you're not subscribed, make sure you click the subscribe button and help me make my day, I guess. I don't know. Is that good? Or if you just want to watch a video, then watch a video. I'm not forcing you to sub, so yeah, that's that. But anyways, enough of all of that rubbish. Let's get into this. So, after I uploaded my last video about turning Saturn into a star, I got 2 comments saying turn Ganymede, which is the largest moon in the solar system in orbit of Jupiter, into a star. So, I actually really like the idea of this. So, we're going to this is like a bonus episode.